Hey guys, Mr. T with another video here. This one is on considering errors in bearings. So for this course you're required to consider the effect of errors on your scale diagrams and also on bearings problems, which is what this video is about. So error will often be expressed as a plus or minus percentage, example, plus or minus 5%. Sometimes it'll just be expressed as plus or minus a number of degrees, which makes it really easy. You don't need to have any further calculations, but oftentimes you'll have it as a percentage. So in the case of bearings, because the bearing is a direction that goes clockwise of true north, which true north is 0, 0, 0 degrees, the error is going to cause the bearing to be less clockwise if you're talking about the negative error. So say your negative 5% error, you're going to be 5% less clockwise from true north than the actual bearing that you're told. And if you're in the positive error, so say plus 5% error from the bearing, you're going to be 5% further clockwise by a certain amount. Now that certain amount, the amount of error, otherwise known as the absolute error, can be calculated by finding the value of the percentage compared to the value of the bearing. So the absolute error in the bearing, which is going to be given in degrees, is going to be the percentage error. So the percent, in this case, would be 5 over 100. And then find the answer to that and then times it by the bearing that you're given, the bearing that it's supposed to be. And that'll tell you how much out by an actual number of degrees the bearing will be. It'll be less clockwise for the negative part of the error and more clockwise for the positive part of the error. So let's run an example here. Example, a radar tower indicated that a plane flew over it in the direction 075 degrees true. Don't worry about that true thing, that's just the same as our bearings that we've done. The true indicates that we're comparing it to true north. The radar tower has a plus or minus 8% degree of error. Draw a diagram indicating the direction of the plane from the tower and the possible lines of flight considering the error. So let's get started. We need to draw a diagram as if the plane flew exactly as it was supposed to. So the tower's here. Indicate true north, which is going to be straight up and down. Use a ruler, square it up with the edge of your page. In my case, the edge of the iPad screen. That's true north, that's 0, 0, 0 degrees. I need my protractor. Done. Line the 0 on the protractor up with true north on my diagram. Again, taking forever because every time I move my finger it moves. That's alright. Line it up with the center, line it up with a tower. Line the center of the protractor with the tower. The direction is 075 degrees true. Therefore, we go clockwise from true north. That's 60, that's 70, that's 75. There. So put a dot. So, if the bearing was exact, the plane would have been flying in this direction. Because that is 075 degrees true. So that's what we think so far. However, the radar tower has an 8%, plus or minus 8% degree of error. Draw a diagram indicating the plane's flight and the possible lines of flight. So I've done the plane's flight, ignoring the error. Now we need to do plus or minus the degree of error. So, do some maths. Absolute error is going to the percentage error, 8% over 100, times by the bearing, which is 75. 8 divided by 100 is 0.08, times by 75. It's going to be 6 degrees. So that's telling me 8% of 75 degrees is going to be 6 degrees, and the tower can be plus that amount or minus that amount. So it's either going to be further clockwise by 6 degrees or less clockwise by 6 degrees. So that gives us 2 marks for possible flights. 75 plus 6 is going to be 81. So that's one of your possible lines of flight. And 75 minus 6 is going to be 69, which gives the negative line of flight. So now we can draw from the origin, from the tower, because you've admitted that the tower can have an error of 8%, the plane could be flying anywhere between these lines of flight, which are 6 degrees less clockwise or 6 degrees more clockwise than the bearing it's supposed to be flying on, because of the error in the readings. So you could indicate that by going, this one is 0.81 degrees true plus 8%. And this one is 0.69 degrees true, that's minus 8%. So that is showing how you indicate or take into account the effect of error. I've done the whole example for using percentage error. Obviously, if your question just said that the tower has a 10 degree, plus or minus 10 degree error, you don't need to do this math. You would just go 75 and then minus 10 from it and add 10 from it. So that would save you a calculation. But in this case, I want to do the hard version of finding the error if you're given it as a percentage. Hopefully that helps you out, and I'll see you on the next video.